So as we've kind of finalized surface area of shapes, remember, first off, we're talking about surfaces. Remember, surface is a two-dimensional kind of space, if you will. So remember, since we're talking about a two-dimensional surface, it's always measured in square units. So make sure you always use labels like inches squared, feet squared, centimeters squared. Whatever that unit of length is always going to be squared. So miles squared, kilometers squared, things like that. So surface area is going to be how many squares it takes to fill up that space. So if we're talking in inches, how many square inches, how many 1 by 1 inch squares does it take to fill up that space? So again, notice how it's hard to really draw this all out. So that's why we take advantage of formulas to determine what we call the surface area. So some surface area formulas that if you want to make note of, they're also in your textbook that you can find them there. So for the cube, surface area is going to be this 6 times s squared. Remember, s squared represents the area of a square. And remember, a cube has 6 faces. So once I find the area of one face, which is a square, then all I got to do is multiply by 6 to find the area of the whole cube or the surface area of the whole cube. So some of these may make sense to you without um, actually having to memorize the formulas. So they're saying S represents the length of one edge. So notice that if you're, you know, if we're talking like a square, we would call it a side. But when we're talking about surfaces, you know, a side is actually like a face and an edge is more like point to point distance. So pick up on that depending on what type of shape you are, some of the words will get interchangeable. So S is actually the length of one edge. So notice that a face could be considered a side, if you will, if we're talking about a three-dimensional object. So we're talking about S is an edge, a point-to-point distance. So a rectangular prism or a box, notice how the front face and the back face are the same. The left face and the right face are the same. What do we have left there? Top and the bottom are the same. Notice how we have to find the area of one, like the front face, the left face, and the top face. Once I find those, if you multiply that all by 2, that will give you the total surface area. So if you add those three areas together and double it, you can get it that way. And sometimes this formula, let's see if I can get this pen to work. Okay, so hold on a second. So sorry about that. Had to get my pen to work here. So notice how we could use some algebra and distribute through the formula and say the surface area is going to be like 2 times the length times the width plus 2 times the length times the height plus 2 times the width times the height. So you can modify the formulas as well by using some of the algebra here. So that's where you're taking Math 141. In this area here, in this section here, we're kind of marrying some geometry with some algebra techniques. So again, the length, width, and height are actually edges of the prism. So keep that in mind. So to find the surface area of a cylinder, remember there's a top and a bottom, those circular bases, and then that curved side. So there's actually 3 different things we have to do. So 2 times pi r squared will find the area of the top and the bottom, and then 2 pi r times the h. Remember that calculates the area of the wraparound piece. So remember the wraparound piece actually turns into a rectangle, but in the form of a circle, it's going to be this 2 pi r times the height. So remember 2 pi r is the circumference and then times the height. Okay. So again, notice how here R is the radius. So that's going to be from the center of the cylinder out to the edge of the circle, or to a point on the circle, if you will. So remember, the radius is kind of tied to the top or the bottom of the cylinder, where the height is going to be the distance from the bottom of the cylinder to the top of the cylinder. So sphere completely round, notice how we had this formula, surface area equals 4 times pi times r squared. So r is going to be from like the middle of the sphere out to the sphere itself. So it's actually going to be like from the core inside of the sphere coming out to a spot on the sphere, on the surface of the sphere. So that's the radius. So remember, if asked to, this pi, if the book asks you to change it to 3.14, do so. And then we have to round to the according to the desk place that they want. Otherwise, if they don't want us to change pi to a number, just leave pi in the problem, and then it becomes kind of more algebraic because pi becomes almost like a letter, if you will. So a cone is a lot more complicated. So notice how we have the circular base. Notice how the radius goes from the center of the base out to the base of the circle. And then the slant height, like, is the outside distance, and the height is actually from the apex to the radius. So the vertex is actually, so it's the apex is this spot up here on the cone. So it's kind of perpendicular with the base, if you will. So the curved lateral surface area is, it kind of connects the apex up here, that point up there, that vertex point. So it wraps around the bottom base and this little point up here. So it's an unusual shape. So notice how to find the slant height, we had to use the Pythagorean theorem. So notice how the slant height, since it's the hypotenuse, is going to equal the r squared plus the h squared. But remember, to find L, you have to take the square root of it, because remember, it's L squared equals h squared plus r squared. So then it turns into L equals the square root of r squared plus h squared. So again, the surface area of a cone, the base is a circle, so it's pi r squared. This lateral surface area is pi RL. So so the total surface area is going to be the area of the base plus this, what they call the lateral area. But sometimes instead of L, you may have to solve for L. So to solve for L, we may have to substitute in there. So we may have to replace L with the square root of r squared plus h squared. So notice how the surface area is pi r, and replace L with the square root of r squared plus h squared plus this pi r squared. So they actually did a little bit of factoring here too. So that this would only be really if I knew what the slant height was. So there's actually three formulas: this one, and this one. Notice that they're actually saying total surface area. A lot of times our book just simply says S for surface area, or sometimes I like to use SA for surface area. But in your problems, they may just be using S to represent the total surface area. So those are the big formulas. Next, we're going to get into volume. So that's going to be in our next video.